Today, we will be learning how to solve equations involving polynomials by factoring. We've been talking about polynomial functions, cubic functions, quartic functions, eighth degree functions, and we remember that in an nth degree polynomial, there are n zeros. Here, we're talking about an nth degree polynomial equation, and it has the corresponding n solutions. So for example, an equation involving a cubic function will have 3 solutions. An equation involving a quartic function would have 4 solutions, etc. Sometimes the solutions might be non-real, and sometimes they might be repeated. So just take a minute to write down that it includes non-real and repeated solutions. So let's check out our first example. In our first example, we want to know when 2x cubed minus 10x squared equals 28x. You might remember that we can solve this by graphing on our graphing calculators by setting one side into y1 and the other side into y2. If you do that in your graphing calculator, you will end up with 3 intersection points, just like you expect in a cubic function. So if you have your graphing calculator, you can put those 2 equations in and solve. But the other way you can solve this is by setting the equation equal to 0 and by factoring it. So to solve by factoring, the first thing we need to do is set the equation equal to 0. So I'm going to subtract 28x from each side, and I get 2x cubed minus 10x squared minus 28x equals 0. Make sure that's a cubed on your paper. Then I notice that I have a GCF here. My GCF is 2x. That leaves me with x squared minus 5x minus 14 equals 0. And this is a factorable quadratic, so we get 2x times x minus 7 times x plus 2 equals 0. Finally, just like we did when we were finding zeros, is we find the x values that make the equation true, that make it equal to 0. So x can be 0, x could be 7, or x could equal -2. So our steps were, first, set the equation equal to 0. Second, look for a GCF. Third, do any additional factoring. And finally, solve for x. Let's take a look at another example of how we can use factoring to help us solve. For this second example, I already made a graph for you just to remind you that since this is a quartic function, we are looking for 4 solutions, and that we want to know when it equals 0, so we can really look at the zeros on the graph if we want to. And you'll notice that we have one solution here with a multiplicity of 1, one solution here with a multiplicity of 2, and then another solution here with a multiplicity of 1, which gives us our quartic function. Our multiplicities add to 4, and this is our repeated 0, and that's why we end up with 4 solutions, but one of them is repeated. So if I were to solve this by factoring, again, I would look for a GCF. Here my GCF is 3x squared, and I would be left with x squared minus 9. I still have my equals 0. This quadratic here factors more to x plus 3 and x minus 3. Finally, I look for the x values that make the equation true. X equals 0, x equals -3, and x equals +3. And even though we're looking for 4 solutions, we notice that this one has a multiplicity of 2. It occurs twice. So we've accounted for the fact that we need 4 solutions, and we have 1, 2, and 3, 4. That solution gets counted twice. Let's see what happens when it's not quite as clear-cut from the graph. In this last example, this is already factored for us. We have this factor, and then we have a second quadratic factor, but this one is not factorable. And because it's not factorable, we know that we'll need to use the quadratic formula to solve it. But before we go ahead and do that, let's just check out what's going on with the graph. If I graph this function, if I put this in for y1, then I only get 1, 0 that I can see on this graph, which means there's something funny going on because this is a cubic function, so we are looking for 3 solutions. Well, let's see what happens when we try to find where the other solutions are coming from. From our first factor, this one here, we get x should equal -2 to make this equation equal 0. But from our second factor, when we set this equal to 0, we need to use the quadratic formula to solve. Well, let's see. X equals -3 plus or minus square root 3 squared minus 4 times 1 times 5 all over 2 times 1. Well, when I solve this, it looks like inside my square root, I get 9 minus 20, which equals -11. And if you recall, when our discriminant is negative, this means that we have non-real solutions. So at this point, you can just write x equals -3 plus or minus the square root of -11 over 2, and you should remind yourself that this is 2 non-real solutions. So you found 2 non-reals and 1 real for your total of 3 solutions. There's 4 problems on the back that you should try as well, and we'll see you tomorrow. Don't forget to complete your survey.